worst word in mathematics to hear or see. No, not easy. This is, have I told you this? In a math textbook, if you ever see that word, it's clearly. Sorry, you're like, I don't know that word.
It's a really bad thing.
That's pretty funny to do it clearly. Here's the thing. No, it'll take a second, but this is what. No, but listen. I understand, but raise your hand if you would like to talk about 29. There was a few people. See what I mean? The point is this. The reason clearly is such a dangerous word to use in mathematics or see in print is because either you find it obvious and you don't need the book to tell you that, or you don't and the book just kind of went like, yeah, making fun of you. You know what I mean? Like, there's no real reason it needs to be there. So just because it looks pretty easy doesn't mean it is for all people. So we have this right here, and we have x is equal to 3 over 2y. Two different lines. When it says to use substitution, is something already isolated for you? Yeah, x in both cases. You have two choices off the bat. If this was me, I would take the second one and I would plug it in up there. Sorry, for x, not y. So what do I write? 3 over 2y is equal to what? 3y plus 5. And then maybe subtract 3 over 2y. You get 0 equals what? How many halves are in 3? How many halves are in 3? 6. So 6 halves minus 3 halves is? 6 halves. Okay. Yep. So we have 0 is equal to 3 halves y plus 5. If we want to solve for y, what do we need to do to both sides? Subtract 5. Negative 5 is equal to 3 over 2y. What do I multiply both sides by now? 2 over 3. So you get y is equal to negative 5 times 2 over 3, which is negative 10 over 3.
I don't know what I do.
So what do you do? What do you do now that you have the y value?
Wait, just ask a question.
Yep.
Why do we go from y, 3 half y equals 3y, and then just go straight to 3?
Because we did 3 over 2y is equal to 6 over 2y plus 5. And we subtracted 3 over 2y from both sides. You get it now?
Can you multiply by the reciprocal?
At this point?
Well, like on the, when you multiply it.
You don't want to multiply the reciprocal unless you've isolated a little bit further.
Oh, that was,
What did you do right there, right after the negative 5?
What did I do? I multiplied both sides by 2/3. Why did I multiply by 2/3 on both sides?
So you can get y by itself.
Correct, because when you multiply 3 halves by its reciprocal 2/3, what's 3 halves times 2/3? 1. So there's an invisible 1 there now, which we don't write in, but we could. So y is equal to negative 5 times 2/3. Now that we have y, what do we do with it? Plug it in to either one. We can plug it in right there. We get x is equal to 3 halves times, was it negative 10 over what? 3. So that equals negative 10 over 2, which is what? Negative 5. How do you state the answer once you have these numbers? Negative 10 over 3, comma, negative 5. Stated as a point.
Wait, isn't it?
Oh, you're absolutely correct.
Useful.
You have it in my notes theoretically, but I can if you need me to. There you go. To use elimination. Elimination, you need to get opposite coefficients on one of these, so when you add them together, one thing goes away. So in this case, you really do need to multiply both. That's the best way to go about it. You don't have to, but it's the best way. Can you put your tablets down in tablet mode, please? Thank you. What should I multiply the top by, and what should I multiply the bottom by? Anybody want to guess? Top by what? So you want to multiply that one by negative 3. So if you do that one by negative 3, what do you want to multiply the bottom one by? Negative 3 and 4? There's different ways to multiply, absolutely. But if you do that multiplication, someone else, Noah, can you tell me what the top line becomes if you multiply by negative 3?
Negative 9.
Yes.
Minus 12.
Y equals? Correct. And Verdi, can you tell me what the bottom line becomes?
Yeah, 20x.
Yep.
Plus 12y.
Yep. Correct. Now, what's the nice thing about when you add these together now? What's the nice thing that happens? Meg, what's the nice thing that happens? Meg. Yes, Meg, what's the nice thing that happens when you add them together? Yeah, and what are you left with, Meg?
11x equals 22.
So x is equal to?
Could you have used positive?
Okay, kids, If words are actually coming out of my mouth, just wait until the sound waves stop and then speak. Or raise your hand. Meg, what's it equal? 2. Once you get x equals 2, what do you do with that x equals 2? Yeah, you could do y if you want. You could. You should. But now you can plug it into either one you want, right? So you have 3 times 2 plus 4 times y is equal to negative 6. So 12 plus 4y is equal to negative 6.
12.
6. Sorry. So what do you get? 4y is equal to negative 12. So what does y equal today? Minus 3. So what's the answer? 2 comma? I love the answer written as a point. Yes?
Couldn't we have just multiplied the equation by positive 3? And
Which one?
You
can multiply by positive and then you have to subtract. Yes, you can absolutely do that. Just remember when you subtract, you have to subtract every single term, not just the one that goes away. Okay? You can absolutely subtract instead. I like aiming for addition because generally speaking, doing the negatives first eliminates a few of the errors that come when they do a lot of subtraction. Okay, someone pick this. Do this the same way. For elimination, you need to pick things to multiply them by, right? So anybody want to guess? Let's just try something. Sarah, can you? Oh, do you not have your stylus again? I'll go get it. But what should I multiply the top by, and what should I multiply the bottom? I love that idea. 5 and negative 3. So if I multiply by 5 and negative 3, can someone tell me what the top becomes if I multiply by 5? Noah. No, sorry. Noah?
15 over x
Yep.
plus 20 over y.
Yep.
Equals, no, not
25 over 2. And someone else. Can someone else tell me what the bottom becomes? Hannah, what's the bottom become?
Plus.
Negative 15 over x
Over x.
plus
9 over y.
equals.
Negative 20 over.
Correct. Now can we add these things? Can we add them together? Yeah, if we add them together, what happens here if you add these together? And then what's the next one become? 20. Yeah, because we already have a common denominator. And what's this equal? Well, it's 25 over 2 minus 21 over 4. So that's 50 over 4 minus 21 over 4, which is equal to what? What's it equal to?
29 over 4.
29 over 4. So what do you end up with? 29 over y is equal to 29 over 4. So what does y equal?
4.
Done.
That was the answer for the whole thing.
No, what do we not have yet?
X.
But we're done with this part of the problem. Ah, are we very close to done? Yeah, you take that 4, and which one do you plug it into? You plug it into x where?
Wherever.
Either one, right? They both need to be true, so theoretically you pick either one, right? So how about we pick this one right here? 5 over x minus 3 over 4 equals 7 over 4. What do you do to both sides? You could multiply. Yeah, we could multiply, but what do we add to both sides? We're trying to isolate.
3/4.
So what should we get rid of? No, we're not isolating 3/4.
Isolate x.
We're isolating x. What should we get rid of?
Negative 3/4.
Yeah, so we add 3/4 to both sides. And what do we end up with? 5 over x is equal to 10 over 4. What do you do when you have a fraction equaling a fraction like this? Yeah, so 5 times 4 is equal to 10 times. So 20 equals 10x. What does x equal? Answer is going to be 2 comma 4. Not as bad as it seems. No, it's not as bad as it seems. That being said, it looks different, so it might freak you out, but did you use the same methodology? Yeah, it specifically said use elimination. What method are you guys most comfortable with? Probably because you've used it the most often. Substitution. Now here's the trick on this one. If you use substitution on this one, is that actually a little bit hard? Yeah, because what's the first step in substitution? Not eliminate. Isolate, right? So you look at this and you say, do you really want to isolate anything here? It's not very nice. Because look, if you want to isolate y, you can put that over there. You can't just flip all the fractions. You have to combine them and then flip. Elimination works really well. It's like, literally, was this that bad right here? That could be a lot worse. And I'm telling you, substitution is worse. So if I gave this one to you, I would probably say use elimination or direct you in some other way. Like, if you use substitution, don't. You know, like, yeah. Just systems of linear equations in 3 variables. What am I talking about? We've been doing 2 variables, x and y. We're going to add in a 3rd variable. Do the z. We're going to call it z. That's correct. We could call it anything we want, but x, y, and z are the common triple. Does the process really change that much? No. There's only two methods really of the three that we can do though. Which, exactly. Can anybody explain to me why we're not going to be graphing them? Anybody know why? Yeah.
Because you've got like totally different planes.
Yeah, it's plane. So what, in 2 dimensions, when you graph a system, you have one line, and then you have
Like,
another line, and you look for the intersection point.
yeah.
What do we now have though? Instead of lines, we're going to be looking at planes. Planes. They're flat surfaces that extend infinitely in 3 dimensions. So we're going to get systems that look like this. And here's the thing. Listen, is this something that I could reasonably expect you to do by hand and then estimate? No, not at all. There's also different possibilities. So for example, you could have 3 planes and they all intersect in a what? What's the intersection called right now? That's that's a line, right? They could all be the same plane. They could all intersect in one point. Hey, that would be an answer. They could all be parallel. How many points do they? None. They don't intersect at all, right? Or they can intersect, but where do all 3 intersect? Nowhere, right? So they're not parallel, but there's no solution, right? You could have a triangle, you could have 2 the same. There's different outcomes here. What you need to focus on though is you're not graphing these by hand. You're not graphing them by hand, but you will need to use substitution or elimination. The process doesn't change. The opportunity to make careless mistakes grows because there are more numbers to deal with. There are more numbers to deal with. Now in your book, you're going to see steps written out. You're going to see longer ones written out like this. We're not going to go over this piece by piece at the moment because I find it much more helpful to actually try doing one. Which method, let's be honest, which method are we most comfortable with? We are. So this is what a system could look like. This is what a system could look like. How many variables do you see? 3. If you had to give a name for the type of equation this is this slope-intercept? No, what does it most closely resemble?
Standard.
This is standard form. This is standard form. And it's really helpful because it shows you the x's, the y's, and the z's. So we could use elimination. Let's use substitution. The method doesn't change. What's the first step in substitution? Isolate a variable. Now, are any of the variables look like they're decently isolated? Middle one what? What variable, which equation? Got it. Or z in the, let's do z in the top one. Okay? So if I'm looking at z in the top one here, what do I need to subtract from both sides? So you get z equals 2 minus 4x plus what? 8y. Now, we did do minus. Thank you, minus. Thank you. Yeah, minus. Got it. Now, what was the second step? Remember, the methodology doesn't change. What do you do with the z? What?
4x minus 8y.
Because we subtracted 4x. We need to subtract 4x. We need to subtract 4x. We need to subtract 8y. And we need to subtract 8y. So, we isolated. Now we need to substitute. Where do we substitute it? Which one do we substitute it into?
Out of the 2 we didn't use in the
The
list.
easier one?
No, both. You substitute it into both. Look what happens. If we substitute this in here, we get x plus 7y minus 3 times what? 2 minus 4x minus 8y equals negative 14, top one, right?
Yeah.
And now let's substitute it also into this one. What do I get? 2x minus 3y plus 2 times 2 minus 4x minus 8y. All we did is find a new value for z. And what did we do with this new value for z? We plugged it in and we ended up with this. Now here's the thing. How many equations do you see right there? 2. How many variables are in that? That's 2 equations and 2 variables. X's and Y's, right? There's only X's and Y here. There's only X's and Y's here. Now we're back to what we're comfortable with. We've taken a 3x3 system. What would be our first step on this, do you think? Hold on. Like you said, a lot of great things. We'd like to isolate, but before we isolate, what should we do? Why are we distributing? Because overall, what are we trying to do? Simplify. Get it smaller. I like that. So if you simplify the top one, you end up with x plus 7y minus what? Notice minus 6 plus what? 12x plus 24y is equal to negative 14. Does everybody see where that came from? Let's just simplify this one first. How many x's do you see? I see 1 of them, 13 of them. So what is that, 13x?
Yeah.
7y and 24y is what? 31y. And if I add 6, what do I get? Negative what? 8. Hey, does that look like, what form is that in? Do we like standard form? Yay, we do. So we've done that to the top one. Do that to the bottom one for me right now on your own. Have the answer for me? What's the second equation going to be? Negative 6x minus 19y is equal to what? Negative 1. Who agrees with that? Okay, so here's the thing. How many equations do we now have? 2. 2 variables. So theoretically, could you use one of your methods to solve this? Maybe you're not that excited about it because the numbers aren't the best. They're a little bigger. But theoretically, you do some work and you end up with x equals something and y equals something. What do you do, though? Are we done yet if we have just x and y? You plug those in. Oh, look what we have here. If we get x and y, what can we find? Z. So my point is this. The process. Is the process really that new? No. Is it a little bit more work? Yes. The answer is going to look like this. A number x, comma, a number that's y, and a number that's z. Your answer is going to look like that. I'm pausing here because I'm not going to take the time right now to finish this. I just want you, do you understand the process? Hannah. If I wanted to use elimination on this one, what would you multiply the top one by, and what would you multiply the bottom one by? I would do 6 here and 13 there. Now, the number's a little big, yeah, but it could be worse. It could be a lot worse. Believe me, I should give you the really hard one. You're like, oh, so kids, tonight, your homework is 150 questions. What's your standard reaction if I said that? Nope. Okay. It's only 50. Dang it. You're supposed to be like, oh, that's great. I'm just trying to make the point that everything's relative, okay? Can the numbers be more ugly? Yes. In this case, you multiply by 6. What's 6 times 13? What's 6 times 10?
60.
What's 6 times 3? What's 18 plus 60? 78x.
I did it first.
Plus, what's 6 times 30?
Okay.
Sarah, what's 6 times 30? Sarah Sadea. Sarah Sadea. I know, I see. I know, we're talking about the hearing thing today. 6 times 1? What's 6 plus 180? 186y equals negative 48. 13 times 16. Oh, we know what that is. What is it? Negative 78. Negative this time. Then you need to do 13 times 19, which might be a little tough. What's 13 times 19?
31 times 30.
No, it's 13. So 13, 19. You know, if I had to do that in my head, you know what I would do? I would do this. I'll just tell you what I would do. 13 times 20. Minus 13. What's 13 times 20? 260 minus 13 is? 247. Equals negative 13. So we add them together. Does everyone understand how I got 247? What's 13 times 20? It's 260. What's 260 minus 13? So I had 20 of them, so I took away one of the 13s. Everybody, please, heads up if you can. If I add these together, what's the thing that goes away? The x's, it goes away. And then the bottom one, what does it become? Oh, now we just need to do addition here. What's 6 plus 7? 13. 8 plus 1 and 4 is? 13. 2 plus 1 and 1 is? 4. Equals negative 61. So here's the moral of the story, everybody. Sometimes will you get nasty fractions? Yes. Yes, correct. I would give you the appropriate amount of time, but yes, I expect you as high school upperclassmen to be able to multiply 13 times 19 without the aid of a calculator. I understand. There's a difference between calculator dependent and being crippled in the world of math, okay? There's a difference. No, you're not. You're definitely not.